The sun's poles are flipping. What does it mean for us? The sun, a giant ball of plasma, is not just the source of warmth and light on Earth, but also a dynamic star full of fascinating mysteries. One of its most intriguing phenomena is the periodic flip of its magnetic poles. Unlike Earth's gradual magnetic shifts that take millennia, the sun's shift is fast, occurring roughly every 11 years. But what does this mean for us? Is this just an amazing cosmic dance? Or could it have tangible effects on our planet and our lives? Today, we're exploring every detail of this event to unravel the sun's magnetic story. At its core, the sun generates a powerful magnetic field. Like Earth, it has magnetic poles, north and south, that are tied to this field. However, while Earth's magnetic poles move slowly over time, the sun's magnetic field is incredibly dynamic. This is because the sun is made entirely of hot, electrically charged plasma that flows and churns. These movements constantly tangle, regenerate, and reshape its magnetic field. The sun's poles don't just stay fixed, they flip. This means that what was once the solar North Pole becomes the South Pole and vice versa. This dramatic change is part of the sun's solar cycle and plays a major role in its activity patterns. Every 11 years, the sun completes a solar cycle, which includes the pole reversal. During this process, the magnetic poles literally switch places. This shift occurs because of a buildup of magnetic forces near the sun's equator during the cycle. These forces become so strong that they eventually lead to a polarity flip. This flip isn't random, it's part of the sun's internal dynamics. Scientists continue to study this fascinating process to understand how these flips affect the sun, Earth, and the solar system as a whole. The sun's activity goes through predictable highs and lows during its solar cycle. This cycle starts with a phase called solar minimum, when the sun is relatively calm with fewer sunspots and flares. Over time, activity ramps up, culminating in solar maximum. This is the peak of solar chaos, marked by an increase in magnetic activity, sunspots, and explosive events like solar flares. The pole flip happens around the solar maximum, signaling a new chapter in the sun's cycle. As the poles stabilize after the shift, the sun begins its transition back into a solar minimum, completing the cycle. Solar maximum is the stormy peak of the solar cycle. During this time, the tangled magnetic fields on the sun's surface trigger solar storms. These storms result in phenomena like sunspots, dark patches that indicate intense magnetic activity, and solar flares, massive bursts of energy that shoot out into space. One of the most significant occurrences during solar maximum is coronal mass ejections, CMEs. These are massive bursts of charged particles that erupt from the sun's surface and race through space at millions of miles per hour. When these particles interact with Earth, they can cause disruptions to our technology and beautiful auroras in the night sky. Let's take a closer look at these explosive events. Solar flares are sudden energy releases near sunspots that send out intense radiation. Though the radiation doesn't reach Earth's surface, it can interfere with satellites, GPS systems, and even radio communication in severe cases. On the other hand, CMEs involve enormous clouds of charged particles being hurled into space. If these clouds collide with Earth's magnetic field, they can cause geomagnetic storms. These storms have both spectacular and hazardous consequences. When charged particles from CMEs reach Earth, they interact with our planet's magnetic field and atmosphere. This interaction energizes particles in our upper atmosphere, producing the stunning glow of auroras, nature's own light show. These lights are visible at high latitudes near the poles, often referred to as the northern lights, Aurora borealis, or southern lights, Aurora australis. During intense solar activity, auroras can become more vibrant and visible even at lower latitudes, offering majestic views for those lucky enough to witness them. While auroras showcase the sun's beauty, its magnetic activity can also reveal its more disruptive side. Modern civilization relies heavily on technology, and solar storms pose risks to these systems. Strong geomagnetic storms can disrupt satellite communications, including weather forecasts, GPS navigation, and telecommunications. Airplane navigation systems flying near polar routes are also affected. Beyond communications, solar storms can overload power grid systems, causing blackouts, as seen in events like the 1989 Quebec blackout in Canada. With an ever-increasing dependence on technology, these risks make understanding solar activity more important than ever. The sun has already proven its ability to cause significant impacts on Earth. One famous example is the Carrington event of 1859, the most powerful geomagnetic storm ever recorded. Telegraph systems across Europe and North America went haywire, sparking fires in some cases. Auroras were so bright they could be seen as far south as the Caribbean. Fortunately, such major events are rare, but they remind us of the importance of monitoring the sun's behavior. A common misconception is that the sun's pole flip is the same as Earth's pole shift. However, they are fundamentally different. Earth's magnetic poles move gradually over tens of thousands of years due to slow processes in its molten outer core. In contrast, the sun's poles shift rapidly every 11 years as part of its solar cycle. Additionally, Earth's pole shifts carry long-term geological implications, whereas the sun's flip is a regular, relatively short-term event with implications tied more to space weather and magnetic activity. Understanding the sun's behavior requires continuous monitoring. Space agencies like NASA and the European Space Agency, ESA, use advanced solar observatories to track every detail of the solar cycle. Instruments like the Solar and Heliospheric Observatory, SOHO, and Parker Solar Probe gather data on sunspots, solar flares, and CMEs. This data is then used to predict solar storms and their potential effects on Earth. Early warning systems allow scientists to issue alerts so that satellite operators, power grids, and aviation industries can take precautionary measures. While the sun's pole flip is an extraordinary event, it doesn't pose a direct threat to life on Earth. Our planet's magnetic field acts as a protective shield, deflecting most of the harmful solar radiation. The biggest risks are to technology, not to humans themselves. It's essential to dispel myths of catastrophic scenarios often associated with solar activity in popular culture. Instead, the focus should be on raising awareness of the real effects, especially those tied to our constantly advancing technology. The sun's changing behavior isn't just an astronomical curiosity, it has real-world implications. Understanding solar cycles helps us protect critical infrastructure, from satellite networks to power grids. But it's not just about technology. The sun's activity also offers key insights into broader cosmic phenomena. Scientists learn more about stellar physics by observing solar cycles, applying those lessons to other stars across the galaxy. Additionally, historical patterns in solar activity are being studied for their potential influence on Earth's climate. While the sun isn't responsible for modern global warming, its short-term cycles can affect weather patterns and atmospheric conditions. The sun's pole flip is a powerful reminder of the interconnectedness between the sun, Earth, and the solar system. From the dazzling auroras to the risks posed by geomagnetic storms, this natural phenomenon underscores our star's influence beyond just light and heat. We've explored what the sun's pole flip is, why it occurs, and how it might affect us. We've also discussed the dedicated efforts of scientists to monitor, predict, and prepare for its impacts. The Sun is not just a luminous ball of plasma, it's a dynamic star that drives the cycles of space weather we experience here on Earth. The magnetic pole flip, a cornerstone of its 11-year solar cycle, is both a natural marvel and a key factor in understanding the universe. As science enthusiasts, we're fortunate to live in an era where space exploration and solar observation are at their peak. Let's continue to fuel our curiosity for stellar mysteries and learn from the ever-changing Sun. After all, understanding the Sun better brings us closer to understanding the universe and our place within it. Thanks for watching. We appreciate you being here. If you enjoyed the video, hit like and subscribe for more. Let us know your thoughts in the comments. See you in the next one.